Hello students, welcome to the series lecture of digital electronics. In the previous lectures we have seen the basics of K-map, then we have also solved some of the examples for the 3 variable and 4 variable K-map. In today's lecture we will try to simplify the Boolean expression which is in the form of product of sum. So far we have gone through the examples of sum of product. Let us have a little bit overview of product of sum. Product of sum is simply, I can say that for an example, let's say if we have the expression which is having terms like a plus b into c plus d, right? So this example is simply, it is having two terms and two terms are the additive terms, and then it is, we are going to product of it. So it is called as product of two sum, right? So in this way it is called as POS, right? So how it is being written actually? So in sum of product, what we do is let's say if we have two variables and let's say four combinations are there, then see 0 0 is normally we are writing as a bar b bar, 0 1 we write as a bar b, and 1 1 we write as a b, and this 1 0 we write as a b bar. But product of sum is totally, it is the complement of sum of product. So what we do is this, we'll do the complement of a bar b bar, so that in the equation we'll get as a bar b bar is equal to a plus b. See, if you do the complement of this using De Morgan's theorem, we'll get a plus b, right? So this is how we got all these terms. So for 0 0 it will be a plus b, 0 1 a plus b bar, for 1 1 it is a bar plus b bar, 1 0 it is a bar plus b. It is totally opposite. For 1 we take the bar, right, and for 0 we take the normal variable and then we do the addition, and it is expressed by the capital M, right? So, and it is called as max terms. In SOP we called it as min terms. So for an example, let's say this is the example given to us and we are asked to, let's say, simplify the Boolean expression. Then what we are supposed to do is, see, maximum number is 3, so we can implement using two variables. So two variable K-map I have drawn already. So I will write 0 1 0 1, this will be as it is, but 0 here, that indicates what? B, and 1 here indicates B bar, right? It's opposite of SOP. So here it is A and here it is A bar. So see, 0, the K-map we write 0 1 2 3 like this. So 0 will be here, 2 will be here, and 3 will be here. Now I need to make the grouping. We know that K-map allows the grouping of adjacent cells and only in horizontal or vertical form. So this will be the grouping. So for an example, if I want to make the group of this, I have already made the group, and if I want to write the equation for this one, so how I am supposed to write? I will check that it is associated with which row? This two row and this column. So in this two row nothing common is there, right? So in our equation we need to consider this column only, and that is this B. So we'll write B here, right? So in first term we have B, then we are going to have the term for next term, one more term for this group. So this group is associated with this row, so this row contains a bar, and also associated with this two column, but in that nothing common. So this will be our answer in that case, right? Let us take one more example so that it will be more, you will be having more clear idea. So let us we have, see, here already given that you have to use these three variables. So I'll write A B C here, 0 0 0 1 1 1 1 0. Remember that this is a gray code sequence. Here it will be 0 1, fine. And see, let us mark this. Okay, I made one mistake, I'm correcting that. Rather than writing 1, you are supposed to write 0 in case of POS, right? So see, remember that in the POS we are not making the group of 1, we are making the group of 0, right? So whatever max terms are there, right, you are supposed to write 0 over there in place of that cell. So it is max term. POS you can identify using this sign pi m, right? When it is written pi m, it means it is the equation, it is the sum of POS. So 0 will be here, 1 will be here, 3 will be here, 5 and 7 will be here. Right? So I need to try that maximum number of zeros can be grouped. So I will try to make the group of this 2, right, and make the group of this 4 0, right. And let us try to write the equation for both the group. This group is associated with this and 0 here, that is, let me write for the convenience, that is, it is A, this is A bar. See, this is not B bar C bar, it is B plus C, this is B plus C bar, this is B bar plus C bar, and this is B bar plus C. If you write this, it will be easy for you for writing the equations. So this group is associated with this row, so and this row contains A, plus this group is also associated with this 2 column, and what is common in this 2 column? It is B. So it will be A plus B, this will be first term, multiply by this total 4 zeros, they are containing or associated with this 2 rows, but nothing common is that, and in this they are associated with this 2 column also, and from those 2 column what is common? It is C bar. So A plus B into C bar, this will be your answer. Right. So in this way you can solve the examples of POS. Let me give you one more example of 4 variable K-map, so that it will be clear in your mind that how we can solve the 4 variable K-map example. So I have drawn already, I have represented it with one example, pi of m. You have to simplify this expression. I already drawn the K-map for the same. Okay, let us try to map this data into K-map. So 0 will be here, 1 will be here, 2, 3 will be here, 6, 8, 9, 10, 8, 9, 10, 11, and then we have the 14. So 12, 13, 14 will be here, right? If you don't know how to map this, please go through the basics, my earlier videos of K-map, so you'll get the idea that how to do that. Okay, so see, what we can do is we need to make the grouping of highest number of bits. That is what the K-map says, so that you can get the minimize the expression. So see here, if you look at here it is possible to make the group of this 8 zeros, and then one group can be possible with this all zeros, right? So only 2 groups will be there, and we know that how see, number of terms in your equation, that will be equal to the number of groups, right? So if we want to write the equation for the same, so if you look at this group is associated with 2 row, and this 2 row is containing 0 0 and 1 0. So common from this is this 0, and 0 indicates here it is what? B, right? So I will write B here, and this 4 this whole 0 contains they are associated with all these 4 columns, but nothing is common in those columns, so it will be B only. Then for the second group, if you look at here, they are associated with all these 4 rows, so nothing common from that, and it is associated with this single column, so we need to take that. So it is nothing but it is C bar plus D. So this will be your answer, right? So in this way you can solve or simplify the Boolean expressions of which are in the form of product of sum. Right? We also try to in next lecture we'll discuss the don't care condition in the K-map. Right? In that also I will do the examples of SOP and POS. Till that time, thank you students.